Alright, so we're continuing our journey towards a better understanding of the base 12 version of pi by looking at this diagram. It generates all 360 degrees using base 12 geometry and the geometry of the dodecagon. In this video, I want to go over these geometric shapes that we've created for the circumference of the circle. This large circle with the two smaller circles inside it. And just want to acknowledge that the degree lines that we're creating have a thickness, and they have a thickness of 0.06 root 2, as well as the circumference of our circle also has a thickness, again, of 0.06 root 2. So if we continue up the 45 degree line like usual to whichever ring we're going to, we're always going to start off by going to the lattice point that's in units of 3.2 root 2 from the center. We're going to use that lattice point to mark off our first radius, and we're going to add 0.5 root 2 at a 90 degree angle, and then mark off that circle as well. Then when those circles go down and they cross the other degree lines, we're going to be using their positioning to find the center points for all the small circles. So once we've done that, we're also going to be drawing lines connecting the center points of all those small circles, so that when we draw the small circles, they're going to be overlapping those straight lines, and those are the points that are going to also define that 0.06 root 2 gap between those two circles, same as what we have on the 45 degree line where it crosses the dodecagon. So then what we want to do is connect those points to the ones that are going to be exactly opposite or across the large circle, so that we're basically creating, in a way, two very long, or one long, very narrow rectangle, but really whose sides just keep going off for however long we need them to be to complete the diagram. So then what we want to do is continue up to, again, to the 45 degree line or the 39 degree line in base 12 where it's crossing the dodecagon. And now we want to sort of zoom in on those two squares where they're crossing each other, that group of squares. And we want to, again, 45 degree line, dodecagon line, we want to count 0.03 root 2 along the 39 degree line and have make a point there, access that lattice point, and then on this side of that same dodecagon line, 0.03 root 2 as well. So we have 2 points that are a distance of 0.06 root 2, but now defined by their points on the 39 degree line. So we're going to draw 2 more circles. So then we have our complete 4 circle set, and that really is the circumference. So that sort of shows that these round circles have an element of movement to them, where they can be repositioned and have the line of the circumference going through them as well as positioned so that the degree lines are going through them. They truly are the unit that we're working with that defines both the degree lines and the circumference. So I think I'm going to leave it there for this video. I just wanted to make sure that we knew that all of the degree lines and the circumference are all the same.